Okay, now we're going to take a look at a couple more examples with factoring and then solving. So again, with the factoring, before we decide which of these factoring options to use, we have to take out the GCF and make sure it's equal to 0. So looking at this problem, it's already equal to 0, and there is a GCF. So between 4 and 25, there's not a GCF, but they both have an x. So x would come out. Okay, so dividing by x, remember your exponent rule, it would just subtract by 1. So this would be 4x to the 4th minus 25. Right, so 4x to the 4th minus 25, we want to factor this part here. So don't forget to put your GCF in the front. Here we have two terms, so it's a binomial. They're not perfect cubes, right? This isn't to the third power, but they are both perfect squares, 4 and 25. So I would take the square root of each of these to figure out my a and b to use this formula. The square root of 4 is 2, and then the square root of x to the 4th is just half of that exponent, so it'll be x squared. Square root of 25 is 5. So this is my a and b. I'll rewrite my GCF in front, and I'll do the a plus b, a minus b. So it'll be 2x squared plus 5 and 2x squared minus 5. So now that it's fully factored, I can start solving. So this would just be x equals 0. Okay, so that GCF I took out at the beginning, since it has a variable, I do need to set it equal to 0 to be one of my solutions. 2x squared plus 5 equals 0. I would subtract 5, divide by 2, okay, and then to solve with square roots, I take the square root. So don't forget, solving with square roots, x needs to be alone before you can use the root. So as soon as you have x squared alone, we can do the square root. So this is equivalent to the square root of -5 over the square root of 2. We cannot leave the square root in the denominator, nor can we leave the negative in the root. So I'm going to multiply by the same thing that's in the bottom and the top and bottom. So this will come out to be, I will come out of the top, root 10. 2 times 2 is root 4. So my final answer for that, just this part, will be x equals plus or minus I root 10 over 2. This fraction cannot reduce anymore. I can't divide 2 into the 10 because it's not really equal to 10. It's equal to root 10. So it will not go in evenly. So far, I have 1, 2, 3 solutions. The next one, 2x squared minus 5 equals 0. I would add 5 to the other side. Divide out the 2 before I take the square root. And then now take the square root. So this is going to come out similar to what we have here. This is root 5 over root 2. And I would multiply by root 2 in the top and bottom to get rid of the radical. I'd have root 10 over root 4. So this answer will come out to be plus or minus, because solving with square roots, root 10 over 2. Okay, so once we have the 4x to the 4th minus 25, we had to factor this one out because I can't just take the 4th root to solve. if I took the fourth root to solve, it would only give me 2 answers. But looking at my original problem, I know I need 5. So my 5 answers would come from factoring this out to get x equals 0 as 1, x equals plus or minus I root 10 over 2, so that's 2 more, and then x equals plus or minus 10 root 2, that's 2 more. So that's my 5 solutions. Okay, last but not least, this is going to come out to be 4 terms for factoring. But before I confirm that, I want to have this equal to 0. So I'm going to subtract 8x and add 40. And here we don't have any like terms when I add and subtract this over. So since there aren't any like terms, I want to make sure I write it in standard form. X to the fourth first, minus 5x to the third, minus 8x plus 40. Okay, so this is 4 terms. I don't have any other like terms here, and there's no GCF. So for the 4 terms, 4 terms means we use the grouping or the box method. So I'm going to use the box method here because that seems to be the most popular one. X to the fourth goes in the top left corner, 40 goes in the bottom right. These two go in the, doesn't matter what order. So negative 5x to the third, negative 8x. Okay, so when you're using the box method, if the box is negative in the diagonals, then that means it will be negative in this column and negative in this row. So the GCF between 8 and 40, you could use your calculator for that. So remember that would be the math, need to turn it on. That would be the math key over to number, down to GCD, and I could just do 8, 40. So my GCF would be 8, and it's a negative 8. Between these two, I see an x in both of the boxes, so I would take out an x and choose the smaller exponent. Between these two, I see they both have an x. Choosing the smaller exponent is a 1, so it just stays as x. And the GCF between these two would be 5, and it's negative. Just to double check with your signs, negative 5 times x cubed is negative 5x cubed. Negative 5 times negative 8 is positive 40. So you always want to double check the multiplication. Okay, so I'm going to write this in factored form up here. So this expression factors out to be x minus 5, x to the third minus 8. Now I have 2 sets of binomials. This first set, I know I can't factor anymore. This x doesn't have an exponent. This one, though, I have x to the third, and 8 is a perfect cube. So I know that I have 2 terms, and that would be my difference of cubes. So this minus sign means I would be using the formula with the subtraction. So this just tells me which formula I could use, but I don't use it when I'm factoring. So I have to figure out a and b. The cubed root of x to the third, the exponents would just cancel, and I would just have x. And b, the cubed root of 8. You can use your calculator for that. If you're unsure, you hit the math key. Down to cubed root of 8 is 2. So my a is x and my b is 2. Using this formula, I'm going to keep this x minus 5 in front. And then the formula is x minus 2. And then x squared plus 2x plus the b squared. Okay, so this is x minus 5, x minus 2, x squared plus 2x plus 4. Okay, so this is the x cubed minus 8 factored using the formula, and the x minus 5 is from our original factoring. So this is it totally factored out now. X minus 5, I set them each equal to 0 to solve, because that's our last step. So I would add 5 to the other side. Here's one answer. Add 2 to the other side. This trinomial, we cannot factor it further, and we would have to use the quadratic formula. So quadratic formula you use for when we have a quadratic, meaning our highest exponent is x squared. If this was x to the fourth, we could not use it. So our quadratic formula, we have to know what a, b, and c is equal to. And I'll just write it out here. So x equals negative b plus or minus the square root b squared minus 4 times a times c all over 2a. Okay, so x equals negative 2 plus or minus, and I'm going to evaluate what's under the root here. So when I type it in the calculator, I don't include the square root. I have 2 squared minus 4 times a times c. So you get negative 12 over 2. Negative 12, we want to simplify our radical before we reduce the fraction. So negative 12, the biggest perfect square that can go into negative 12 is 4. So there's our negative 1, 4 times 3. Square root of 4 is 2. Square root of negative 1 becomes our I root 3. So here we'll have x equals negative 2 plus or minus 2I root 3 over 2. And now we can reduce the fraction. So 2, 2, and 2, I can divide 2 into both of these terms above. I would not divide the 2 into the root 3. Right? Whatever's in the root, that just stays the same. So negative 2 divided by 2 is negative 1. 2I divided by 2 is just I root 3. So again, you look at the original, at your highest exponent, it's 4. So I should have 4 answers. So here's 1, 2, 3, and 4. So the reason why we have to further factor this expression is if I just solve this with the cubed root, I would only end up with this answer. But we need to know all 3 of our answers because it's x to the third. So I know I'm going to have 3 intersections, 3 zeros. So this is our 1, 2, 3 from factoring and solving.